Hi viewer, I welcome you to Edim TV. It is the station where you watch and learn. I'll be taking you through Mathematics Form 3 lesson number 18. The topic is further logarithms. I'm your tutor, Lucy Mudoni. Welcome. Today's lesson goes, we are going to look at the further logarithms. We look at the laws of indices and the laws of logarithms. We start by reviewing the indices because indices, it is not covered in Form 3. It was covered last year, which was Form 2. So when we talk about the index notation, there is something we refer to it as the index notation. It's supposed to be C is equals to A raised to power B, where A is the base while B is the index. For example, we have 25 is equals to 5 squared. You can be able to see 5 is the base and 2 is the index. It has been raised to 2, which can be written as, so this index notation, we can write it as log 525 is equals to 2. And that is what we refer to it as logarithmic notation. So in that case now, general equation can be A raised to power B is equals to C, that is index notation, which can be transformed to log A C is equals to B in logarithmic notation. Examples. Convert into logarithmic notation. 2 squared is equals to 4. 4 cubed is equals to 64. 3 raised to power 4 is equals to 81. So when we convert it into logarithmic notation, it will be log 2, 4 is equals to 2. That is the first one. While the second one is supposed to be log 4, 64 is equals to 3. The third one is supposed to be log 3, 81 is equals to 4. Then the next one is supposed to be convert into index notation. You have log 5, 625 is equals to 4. And log 2, 128 is equals to 7. Log 10, 1000 is equals to 3. Into index notation, the first one, part A, can be written as 5 raised to power 4 is equals to 625. And the second one, it can be written as 2 raised to power 7 is equals to 128. While the third one can be written as 10 cubed is equals to 1000. So that is how we convert it into logarithmic notation and index notation. Let us look at the laws of indices. A raised to power m times A raised to power n is equals to A, we open the bracket, m plus n. We hand the powers. And this is only done when the bases are equal. We go to Roman 2, the second one. A raised to power m divided by A raised to power n is supposed to be A m minus n. And this one only applies when the bases are the same. Then we have the third one. A raised to power m bracket raised n can be written as A m n. So those are the 3 laws of indexes. We go on now to laws of logarithms. These ones are derived from the laws of indexes. Log A x y. You have log A x y can be written as log A x plus log A y. Then the second one, which is log A x divided by y, can be written as log A x minus log A y. Then the third one, which is log a x raised to power n, can be written as n log a x. So those are the three laws of logarithms. The three laws of logarithms, we apply them in the topic of further logarithm, while when we go to the indexes, we apply the three laws. Let us go to the other things that you're supposed to note. When you have a raised to power 0 is equals to 1. All the values when you raise it, every number when you raise it to power 0 is supposed to give you 1. The same way, when you have log a 1 is equals to 0. Remember, we have only written it into logarithmic notation, where a raised to power 1 is equals to a. And also, log a is equals to 1. Logarithms to base 10 can be read directly from the mathematical table or by using the calculator, if at all it is base 10. But for the other numbers, we need to use the further logarithms. Let's get examples. When solving logarithmic equations and expressions, the laws of logarithms are applied. For example, solve for x in log x plus log 5 is equals to log 30. In this case, you can use log x is equals to log 30 minus log 5. So we take the like terms together. Using the laws of indices, it can be written as log x is equals to log 30 divided by 5. Remember, the bases are the same. So in that case, x is equals to 6. We go to still another example. We have log 8 raised to power 3. This can't be read directly from the mathematical table. So how do we solve it? We just let the log 8 3 to be equals to x. Thus, 8 raised to power 3 x is equals to 0. So you just write it to be x. So when you write it into index notation, now it becomes that. Then you're supposed to try to solve that. Log 8x is equals to log 3. We introduce log base 10 to both sides after writing it into index notation. In that case, you have x log 8 is equals to log 3. So x is equals to log 3 divided by log 8. So when you divide them, you're going to get the answer as 0.5283 to 4 significant figures. Thus, log 8 raised to power 3 is equals to 0.5283. We get another example. This is where now we have the quadratic equations. We need to get the quadratic equations from the further logarithms. Solve the equation 2 raised to power 2x plus 3 2 raised to power x minus 4 is equals to 0. So we let the 2x to be t. Therefore, t squared plus 3 minus 4 is equals to 0. Quadratic 4 squared plus t plus 4t minus 4 is equal to 0. Solving it, you are going to get x t is equals to either 4, negative 4, and t is equals to 1. So in that case, 2 raised to power x is negative 4 and 2 raised to power x is 1. So when we get that, you are going to get the answers. You have another one there, an equation which you form a quadratic equation. T squared is equals to 3 minus 2t. Then we solve the quadratic equation. Assignment, solve the equation, that one, then solve for t in the following equation. For more information, visit the KRB 2003 Secondary Mathematics Student Book 3. And also, you can get us from the SMSing. You can also get us from the YouTube. You can also get us from the Facebook and from Twitter. Stay tuned to Erim TV.